All right, welcome back, everybody. Today we're going to be going through this patch, which is a infection spreading network built entirely in POPs and TouchDesigner. There's an interactive component, meaning we can heal infected areas of the network, and infection then spreads from node to node. So it will take all of the connections, and if any of the connections to a given node are infected, that node will eventually become infected unless it is healed via interaction. So it's a pretty cool effect. It's actually pretty simple to set up in POPs. This is the entire network, and most of it is just done with regular POPs, although there's just a little bit of shader math, but it's not too bad, so don't worry about that too much. One thing I also want to note at the beginning is that I'm using Sarv's Godrays component for some lighting. That's available for free, so it'll be included in this Dropbox file, or sorry, in the project file. But just wanted to shout it out because it is a really nice post effect. So let's talk about the network a little bit, and then we'll recreate it from scratch. So here we have basically just a little bit of setup. We create a proximity. This proximity is basically going to be our initial network. Then we use a group to seed an infection, and we basically have our infection attached to each one of our nodes. Then we have a little feedback loop. That feedback loop is going to look up our interaction and heal the nodes that our interaction is applied to. We're using the NeighborPOP and a little bit of GLSL for the spreading of that infection along connections. Then we have rendering for our nodes. We have rendering for our connections, our edges, along with a little bit of animation. And then we have some render with a little post. Okay, so it's pretty simple, and it shouldn't take us too long to rebuild, so let's delete everything. I'm going to delete everything but the Godrays because I don't want to have to go find them again. But everything else we'll just delete. And we'll go to our parent parameters. We'll get rid of all of this, so we are completely clean. Okay, so to start, let's get a point generator. And here we can make it about 500 points. This we can drag and drop on our parameters. Then we'll use a noise, and this is going to be amplitude of 2. We should make this a bit of a bigger radius also, maybe like 6. I don't know, something random for the seed, make the period like 3, and then we'll use the proximity to set up our initial network. Maybe maximum distance like 1. Maybe like 1.5. That looks pretty good. So this will be our initial network. And then we'll have a null. We'll call this our initial network. Now we need to do a little bit of infection seeding, but I'll just leave a placeholder for that, and we'll come back to it, because what I want to do first is be able to set up our render. So I'm going to select our initial network, and this one we'll just get a geo straight away. And then I'm going to select this again. This time I'm going to use a sphere. And then from the sphere, we'll put a copy. Sphere goes in the top, our points go in the bottom, and we get a geo. We'll make this sphere much smaller, 0.02. And then I'll set up a render. This render, I'll drag and drop my resolution. This little toolbar, in case you're new, is Function Store toolbar, and it's free. It's open source on GitHub. I highly recommend you grab. Great quality of life improvements, like being able to click this button to open parent parameters. Then I'll Control B. I'll open the palette. I'll grab a camera viewport. I'll drag that onto my render camera top. And we'll drop an out. The very end of our chain, we'll backdrop that. And now we just need to add a couple materials. It can be falling materials first. And actually, I want this to be a wireframe. Okay. So now we have a little bit of a render. It would help, though, if we had a light. Okay, so now we have a little bit of a render. Pretty straightforward, pretty easy setup. Honestly, maybe I'll just put the God rays back in, because why not? And I'm going to turn the samples and the strength pretty far down for right now, because, well, maybe I'll just bypass that for now. It's a little cluttered. It's fine. Okay, so now we basically have our beginning. I'm going to drop another null, put it down here, and this will be our updated network. And so actually, this should be what we select, not our initial network. Okay, so that's pretty good. Now we can move back to our infection. So the first thing that we're going to do is create a little coloration for our infection. So we can come here on our base geometry. We'll create an attribute. One on points. One will be infected. The other is going to be touched. That'll be for our interaction. Those are both defaulting to 0. Now we can do a random. We'll output this random to our infected class, and we'll set it, or attribute rather. And then maybe here in our updated network, I'm going to put a GLSL. We'll call this GLSL color. We'll go back to our attribute page. We'll add a color attribute. Then I'll go to my GLSL. We'll make sure it updates color. We'll give it 2 vectors. This will be U healed color, which can be a vec3, and U infected color, which can be a vec3 also. Let's say our healed color for now will be blue, and our infected color for now will be red. And then float % equals td in underscore infected. That's how we can grab our infected attribute. And then we can simply say color brackets ID equals, and then we'll use a ternary expression. If % is greater than 0.5, then we might want it to be our infected color. And if not, our U healed color. These are both vec3s, so it's probably easiest if we just make them vec4s and make our alpha 1. So now we have some coloration. And if we come here on the copy, we can copy our color attribute to our nodes. But because we have a infected of all 0, and right now it's all blue. But if we use random to output our infection, and we zoom this out a little bit more. Okay, so now we can see we have some random infection nodes set up. If we change the seed, we can see this changing. Importantly, we can also see the lines fade from blue to red, infected to not infected. So now we're starting to see this all work a little bit. But we have to seed our infection in a way that's not just random. I don't actually want to do that. So what we will do is insert a group. This group will be points. We can debug the color of the group for now. I'm going to turn on thinning. I'm going to turn the thin random step way up, like way up. And then we can name the group initial or init infected. Then we'll use a math. We will operate only on that initial infected group. We'll take the input attribute scope of infected and we'll pre-add 1 to it. So now this is setting up our infection seed because these are the two that are going to start as infected. And as we change the seed, we can see that this changes. So that is our seeded infection. This will be our network setup, our infection seed. So then we're going to have a feedback loop. And the feedback loop will be how our infection is actually updated. So first, we can just make it move a little bit so that there's some nicer animation. So I'll add a noise in my feedback loop. I'll add a speed chop to translate that noise in 4D. We'll set the speed to 0.01. We'll make sure that this amplitude is set to 0.01. The periods may be more like 3. And then we'll drop our null end feedback on our feedback. We'll see this animation starting, but we don't want it to get too far out of control. So I'm going to add a math mix. And we'll wire the initial network in as the second input of our math mix. We'll use the mix combine operation. We'll combine our updated P with our input P, that's our initial position. And our scope C will just be a mix weight variable that I'm going to set to like 0.015. And then we can use this mix weight for our combination. And so now we're only taking a very little bit of the updated weight from our feedback. And we can kind of adjust that exactly as we want it. The higher that this value is, the closer it will be to static. So we can make it 0.001 and have like a ton of noise, 0.01 and have just a little bit of noise. Anyway, so this is nice because it allows us to set up the network, have the network connections kind of locked, and then do this animation purely for visual effect, which is pretty nice. A couple other things. We can name this update motion. It's fine. Math mix. This is basically like a seek home. And now we need to do our infection spreading. So in our feedback loop, we can drop a neighbor. We will have this by connections. And then we'll use a GLSL. Now, if you watched my GLSL for Pops documentary, or not documentary, sorry, YouTube tutorial series, then you will have seen the attribute blur and how the attribute blur can be used. We are basically creating a little version of attribute blur here ourselves. And we can also use a pop to dat to inspect our neighbors. So we'll look at specifically the neighbor and number of neighbors. So you might want to turn up your number of possible neighbors. I'm going to keep mine just at 5 though. And so basically we have this num neighbors attribute, and then we have all of our neighbors specifically. So what we're going to do is first get rid of this. So the first thing that we need to do is say what we're doing in this shader. So we are going to use a loop across all neighbors to update and spread infection. So one thing that we'll need is a vector that will be our U rate. We can call it U infection rate, and then we can have a U healing speed. Okay, and we'll use those. So first we can grab input attribute values. So float touched equals td in underscore touched, and by using this sort of attribute input, your input without args means first input, read attribute from the current element. So because our GLSL pop runs on every element, this means grab from our current element. And we can do the same for a variable called amInfected, and we can set that equal to tdInfected. Now, if we have an interaction we want to heal, so if touched is greater than 0, then we can heal. We'll come back to that. Else, if it's not, then we can spread infection. So how do we spread infection? Well, we loop over all neighbors. So first we need to figure out how many neighbors there actually are. So we'll have a uint for that, and we can call it num neighbors, and here td in underscore, and because we have this dat, we know that it's called num neighbors. And grabbing it from this element's fine. And then we write a for loop. For int I equals 0, I less than that new uint variable that we just made, I plus plus. Now we get neighbor ID. That's another uint td in underscore neighbor, right? And here we're going to use a bit of a different syntax. We'll grab the 0th input. We're going to use this element, but then because there's an array and we're looping over this array of neighbors, 0, 1, 2, 3, 4, we'll use I. And so this will get the current neighbor index from array. And then we can use that to look up infected attribute. So our neighbor infected equals, you guessed it, td in infected 0, but in this case we're going to be using the n. So this is going to be our neighbor infected value. If our neighbor is infected, so if this value is greater than or equal to 1, then we'll have our am infected, and we're going to increment this by our u infection rate. And so that tells us what we can do here in our touched. We'll basically just subtract our infection rate times u healing speed. So our infection rate will be like a global, and our healing speed will be a multiple that's attached to it that determines how fast we can heal. So now that we've updated am infected at the very end, we can then write out our new infected value. Infected ID equals am infected. And then all we need to do is in our GLSL enable infected in our output attributes. And we can already see this animation spreading. Drag and drop my feedback restart here, just so I have it, but we can see the spread happening again. Pretty nice, already looking pretty good. And so we're pretty much done here. We can get rid of this pop too. This will be spread infection. Now there's one other element, and that's the interactive element. So let's get a in. I have this little animated interaction wired up already. So what we can do for this interaction is a lookup texture. We'll drag this top on my lookup texture. And now what we're going to do is output to touched. And because we already have in our infection shader something that happens, how we heal if our touched attribute is 1, that means that if we have this lookup text working right, then it should just kind of immediately start healing. But we need to figure out how to read in this texture. Now, a common way to do this might be something like using normalize, and I hate this, so we can use normalize new normal position called NP, and then we use NP to look up our texture. Why is this not working? Input, oh, that's sorry, input attribute, my output attribute should be NP. And if we let this run long enough, we'll see that it is working. I guess it'll be a little bit more clear if I zoom it out, but the mapping is all wrong. And we can get rid of this warning just by turning these off. The mapping is all wrong because our camera is somewhere and we're zoomed in, and this is a radius of 6 in our point generators. So anyway, what is better, instead of using this normalize, is to use actually a texture map. And this is a technique that I found myself using a decent bit. We'll set our texture map to perspective from camera, and then we'll use our camera. This is going to create an attribute called text, and so we can use this text attribute 0 and 1 to look up our touched attribute based on this texture value. Now we can come here in our vector. Let's turn up this healing rate by a lot and see what's happening, because I would expect at this point to see some of our infected nodes changing back to not infected. What's going on here? What am I missing? Let's lock this for now. Okay, so I guess that is actually working, is that right? And this is why it's helpful. I will have a select top. I'll select this interaction, and then at the very end, I'm just going to do a over, because I want to be able to see my interaction and kind of debug what's happening. And maybe instead of the full thing, we'll just do the edge. So now we can see what's happening. There's still something wrong. So give me a minute to sort that out. Let's just set this equal to 0 and see what happens. Okay, so when we set this equal to 0, we can see that our healing is working. It's a little strange. Maybe this just needs to be much bigger. Okay, well, we'll just set this equal to 0 for now, because that seems to work, and that's also fine because we're going to get rid of this snappy recoloring in just a second. The last thing on the texture map is we want this camera aspect to be set to whatever our render aspect is. So I'll, in my Y, set this to render resolution Y over X. And now we can see that this interaction is also a little bit tighter. I'm just going to close all my viewers. And label my interaction mapping section. Okay, so now the last piece is to do a little bit of animation in our render. And so for this, we will move this up here. Render nodes. Come down here. Render edges. Okay, so I want to render the edges. I want to use a line to render the edges, a line material. Now we can do this, but it helps if we use a convert and convert everything to line strips, because we're going to use a line resample divisions. We'll resample to like 100 divisions per. And then, if I move this down here for a second, what this is going to do is let us actually animate the color change along the lines. So we have our line resample, then we're going to use a LineMetrics, line strip, distance start normalized. Then I'm going to use another GLSL, and this we're going to be updating our color. So this is a pretty simple shader. Actually, I'm going to copy this GLSL color because it's very similar. The only difference is that we need a U, and this will be our dist start norm attribute that we got from the LineMetrics. And now we'll say if U is less than our %, then if we create, I guess, like a vec4 called color, we can set this color equal to our U infected color. And if not, we can set the variable equal to our healed color. And then we can just use this color as the output. Now let's see what happens. You can grab this other GLSL color and just put it up here in our nodes, because now we have slightly different coloring logic for the COP, the nodes, and the edges, since we want the edges to be animated, but the nodes are not animated yet. But actually, if we're being real here, what we should do is, instead of having this be a stupid 0.5 like that, we set this to a mix, and we actually just mix between these two guys. Based on percent, and we can clamp that. So percent equals clamp percent 0, 1. And so now we should get a more interesting fade as nodes are becoming infected. And we can probably do that same here, actually. It's a little bit different. We can say something like percent equals smooth step of u minus 0.01, u plus 0.01%. And then we can say color equals mix, u healed color, u infected color, percent. And so this should also get us a nice smooth animation, although I guess it won't be quite as obvious because we're already animating this across 100 intermediate points between each node. That's okay. A couple other look dev things. We can change our distance a little bit and make our width and far a little bit lighter. We can come over here to our line, turn up our near color, make it a little bit brighter, and maybe turn our far alpha down a little bit, turn blending on. And so this way we'll have just a little bit more depth in our render. Can use a transform. Put this all over a black background. Add the God rays back in. And then the very end, maybe we'll just do a little level. Just a little bit. Nothing too crazy. And there we have a nice interactive network. I think I actually might prefer this coloring without that smooth step at all. Maybe it's okay. Let's return here. Now, one thing that I want to try is actually just outputting this infected status here. And then again here. The reason for that is to just make sure that we don't have any same frame issues with propagating our infection. That seems like maybe it just made it worse, so I guess I'll not do that. Very nice. And so we'll wire this up, and we can open up our viewer and see here that our mouse interaction is also working. And the longer that we can hold some of these, the infection and healing will fight itself. So it's a pretty cool little effect. And as you saw, pretty easy to set up in Pops. So that's going to be it for today. I will share this example file on my Patreon, of course. Hopefully you found it interesting, helpful, and maybe learned something. Thank you for the support. Really makes a lot of my life possible, so continued thanks and gratitude. Let me know if you have thoughts, and if you have any ideas for tutorials that you'd like to see in the future, make sure to drop me a comment and let me know. Otherwise, like, subscribe, follow me on Instagram, do all that good stuff, and yeah, have fun out there. Catch you later.